Hello students. This is our next class of quantitative techniques. In the previous classes, we have studied about the LPP and the different methods to solve the LPP. So in the last class, we have studied about the graphical method to solve an LPP. Now in this class, we will study the simplex method to solve an LPP. So the objectives of this PPT is basically, or this video is basically, that we have to understand about the methods to solve an LPP. So one method we have already studied. Now the next method is simplex method. Why simplex method is used, and when we use simplex method, we have discussed this also in the last class, that if we are solving any LPP and that LPP has more than two variables or the two variables, we can solve this method, this problem by the simplex method. But only in the case if we have more than two variables, then what is the issue? Because we cannot plot the three-dimensional equation on the graph paper. So that problem, those kind of a problems have to be solved by simplex method only. So simplex method basically that if any LPP has two variables, it can be solved by both graphical method and simplex method. But if any LPP has more than two variables, then it will be solved only by simplex method. There is no any other method, or we cannot solve this problem by graphical method. So we have to go by the simplex method only. Now there is a situation where we are asking that where we use the simplex method. The simplex method is used when we are dealing with the multiple variables. So basically the thing is that when we the simplex method is used when the graphical method fails. So we use this graphic simplex method when our graphical method fails, and the graphical method fails when we have more than two variables. So simplex method is used in only those conditions where we have graphical two variables or more than two variables. But the main point is that when the graphical method fails, we have to use simplex method. There are two types of variables in LPP when we solve the LPP by simplex method. So we use two types of variable. One is slack variable and the second is surplus variable. The slack variables are those variables which are to be added to the left hand side of the constraint having less than equal to sign. The coefficient of these variables are 0 in the objective function, and these are the non-negative variables. Similarly, when we are talking about the surplus variable, surplus means something extra. Something extra means that if the equation or the constraint having the greater than equal to sign, that means there is something extra to the left hand side of the constraint. So any variable which is the variable which is to be subtracted from the left hand side of the constraint having greater than equal to sign is known as the surplus variable. The coefficient of these variables are 0 in the objective function, and these are also the non-negative variables. So now let me solve any one LPP with the simplex method. So as we told that the graphical method or the simplex method we use for solving the LPP. So the simplex method can also be used for the LPP which is having the two variables. So I am taking a simple uh, problem to solve an LPP by the simplex method. So here we have the as we know that the characteristics of an LPP are the objective function and the constant. So here we have the problem as a maximum z is equal to 4x1 plus 3x2, and the constants are 3x1 plus 2x2 less than equal to 10, 2x1 plus 3x2 less than equal to 8, and the non-negative constants are x1 comma x2 greater than equal to 0. Now the solution of this problem is basically the first step says that we have to convert the given constants into the equations. So the first step of the graphical method was that we have to assume the constants as the equation. Here the first step says that we have to convert the constants into the equation. So the when we have to convert the constants into the equation, so we have studied already the two types of variables, slack or the surplus variable. So we have to see that our constraint having the less than equal to sign or the greater than equal to sign. If my constraint is having the less than equal to sign, then I have to add something. If my constraint having the greater than equal to sign, that means I have to subtract something. So in the very first constraint, I have less than equal to sign, so I will use the slack variable. In the second constraint, again I have less than equal to sign, so I will use the slack variable also. So using slack variables s1 and s2 to convert the constraints into the equation, then when we use these two variables, then the new form of the LPP will be as follows. the max z will be, as we know that the slack and the surplus variable having the sign, having the coefficient as 0 in the objective function. So this will be the 4x1 plus 3x2 plus 0 into s1 plus 0 into s2. And my constants would be 3x1 plus 2x2 plus s1 is equal to 10, and the second will be 2x1 plus 3x2 plus s2 is equal to 8. Now since we know that the slack variables are the non-negative variables, that means they cannot be greater than equal to less than 0. So my non-negativity constraint will be x1 comma x2 comma s1 s2 greater than equal to 0. Now I will prepare the simplex table, and in the simplex table this is the structure of the table. If you go with the concept, with the first column is known as a b dot v dot, the second is cb, then xb, and then x1 x2 s1 s2, and the last one is a theta. Theta is xb upon xk minimum. So I am giving you the definition of all the columns heading, so that we can understand that what are the BV and the CB and the CB and the CJs also. So B dot V dot means the basic variables. Now the basic variables are those variables which give us the identity matrix in the simplex table. We all know that the identity matrix is of the form of the 1 0 0 1 for the 2 by 2, and 1 0 0 0 1 0 and 0 0 1 for the 3 by 3 form. So what the first step says in the table, that we have to write down the coefficient of the constants according to these variables. So in the first constant, my variables are x1 is 3, x2 is 2, s1 is 1, and since s2 is absent here, so therefore the coefficient of s2 is 0. Similarly, for the second constant, it is 2, then 3, then 0, and then 1. Now here I am getting my identity matrix as 1 0 0 1. So this 1 0 is my the first column, and 0 1 is the second column. So s1 is giving me the first column and s2 is giving me the second column. So my basic variables are s1 and s2. Now the next column is cb. cb's are the coefficients of the basic variables in the objective function. So my basic variables are s1 s2. This is my objective function. So the coefficient of s1 s2 are 0 0. So cb's will be 0 0. Now xb. xb column is also known as a solution column, because this is representing the right hand sides of the constant. The right hand side of the constants are 10 and the 8. So xp column is 10 8. This 10 means that the solution of the given constant, solution of the given equation. So this xb column is also known as a solution column. Now the cj's are the coefficients of all the variables in the objective function. The coefficient of the x1 is 4, x2 is 3, s1 is 0, and s2 is 0. Now we have to say that what is theta. Theta is written over here as a xb upon xk, and in the bracket this is minimum. So theta can be explained as the ratio of the corresponding elements of xb column and xk column, where xk column is known as a key column. And what is a key column basically? For the key column, we have to find out the value of z. If where the the most negative value of z is known as a key column. So if we have -4 -3, that means this -4 is the most negative value. That means this x1 is my key column. So how to calculate this z basically? Z is the multiplication of cb dash and xj minus cj. So this is 0 multiplied by 3 plus 0 multiplied by 2, that is 0 plus 0 is equal to 0, minus 4. So this comes out to be minus 4. Similarly for the x2, it is 0 multiplied by 2 plus 0 multiplied by 3. So 0 plus 0 is 0, minus 3 is minus 3. For s1, it is 0 multiplied by 1 plus 0 multiplied by 0, that is 0 plus 0 minus 0 is 0. Similarly for s2, it is 0. Now out of these four values, we have to find out that which one is the most negative value of zj. So the most negative value of z is minus 4. So this x1 is my key column. Now I can find out, now I have the key column, so I can find out the value of theta. So theta is the ratio of the xb column corresponding to the xk column, that is key column. So 10 divided by 3 comes out to be 3.3, and 8 divided by 2 comes out to be 4. Here we have to consider the minimum value of the theta. So out of these two values, this 3.33 is my minimum value. So this column, this row is my incoming row, outgoing row, and this column is my incoming column. That means x1 will be my incoming variable and s1 will be my outgoing variable. So in the next table, s1 will be replaced by x1. So now in this column, in the second table, what the first step says, that in the second table, what we have to do, we have to find out, or we have to make the key element as one. Now what is a key element? So if you see that this one is my outgoing variable and this one is my incoming variable, so the intersection point of these two is comes out to be at this point 3. Now this blue highlighted cell is known as my key element. So in the next table, what I have to do, I have to make key element as 1 and the other element of this particular column as 0. Now the easiest step to make any element as 1 in the matrix is that you divide that particular value by that self only. That means if I have to make 3 as 1, I will divide the 3 by 3. But the concept of matrices says that only 3 will not be divided, the whole row will be divided by 3. So I have to divide the first row by 3. So this comes out to be 10 by 3. This is 1. This will be 2 by 3. This will be 1 by 3 and this will be 0. Now what I have to do, I have to make this 2 as 0 with the help of this one. So I can use my matrices concept by the row operation, or I can use the another concept which has a formula that the whatever the value you have to find out the change value. If you make this value as 0, this 8, 3, 0 and 1 will also be changed. So I have to find out the change value of this 8, 3, 0 and 1. So the concept says that the change value is basically equal to the value multiplied by the key element minus the product of the elements of the second column. Whatever comes is to be divided by the key element. So if I have to find out the value of change value of 8, it is 8 into 3, that is 24, minus 10 into 2, that is 20. So 24 minus 20 is 4. 4 divided by the key element, that means 4 by 3. Now the change value of this 3 is 3 3s are 9 minus the second ideal, that is 2 into 2 4. So 9 minus 4 is 5. Whatever comes is to be divided by the key element. So this value will be 5 by 3. Now the change value of this 0 is 0 multiplied by 3, that is 0, minus 2 into 1, that is 2, and that whatever comes is divided by the key element. So this is minus 2 by 3. Now the change value of this one is 1 into 3, this column, 1 into 3, that is 3, minus 2 into 0, that is 0. So 3 minus 0 is 3. Whatever comes is to be divided by the key element, that is 3. So this comes out to be 1. So this is my second table. Now again from this second table I don't have these values. So I have to find out that which one is my the basic variables. So basic variables are again those variables which gives us the identity matrix. The first column is given by the x1, so this is x1, and second column is given by s2, so this is s2. Or also we can say that this x1 is my incoming variable and s1 was my outgoing variable, so s1 will be replaced by x1. Now this process has to be repeated until we have all the values of z as greater than equal to 0. So now again we have to find out the value of z with the same process, that is 4 into 1, 4, plus 0 into 0, that is 4 plus 0 is 4, minus cj, that is 4. So it comes out to be 0. Then the next value is 4 into 2, that is 8 by 3, plus 0 into 5 by 3, that is 0. So this is for 8 by 3 plus 0 is 8 by 3, minus 3. So this comes out to be minus 1 by 3. Now the next value is 4 into 1 by 3, that is 4 by 3. 0 into minus 2 by 3, that is 0. So 4 by 3 minus 0 is 4 by 3. The next value of S2 will be 0. Now here again we have getting the negative value. So this minus 1 by 3 is my most negative value. So this x2 column is my key column now. Now again I have to find out the value of theta. Theta again the xb upon xk. So this xb is 10 by 3 and xk is 2 by 3. So either I will divide this 10 by 3 by 2 by 3, or I will multiply this 10 by 3 by 3 by 2, the same thing. So 10 by 3 is divided by 2 by 3 comes out to be 5, and 4 by 3 divided by 5 by 3 comes out to be 4 by 5. And out of these value again I have to find out the minimum one. So minimum is this one, so x2. So the intersection point of this S2 column and this X2 column, that is a yellow one and the green one, this 5 by 3, the blue one cell, is my key element. Now again the same concept for the next table, that is I have to make the key element as 1 and the other columns of that particular column will be 0 with the help of that one. So I have to make this 5 by 3 as 1. So the easiest step says that we have to divide this 5 by 3 by 3 by 5 by 3. So either I will divide this 5 by 3 by 5 by 3, or I will multiply this 5 by 3 by 3 by 5. So this comes out to be 1. Again, the concept of matrices says that we have to multiply or we have to divide this whole line by 5 by 3. So 4 by 3 when divided by 5 by 3 comes out to be 4 by 5. 0 divided by 5 by 3 comes out to be 0. Minus 2 by 3 divided by 5 by 3 comes out to be minus 2 by 5. And 1 divided by 5 by 3 comes out to be 3 by 5. Now I have to make this 2 by 3 0 with the help of this one. So I am taking this 0 and I will find out the change value with the same concept. So I have to find out the change value of 10 by 3. So 10 by 3 multiplied by the key element, that is 50 by 9, minus the product of the second diagonal, that is 8 by 9. So 50 by 9 minus 8 by 9 comes out to be 40 by 9, 42 by 9, and 42 by 9 divided by the 5 by 3, it comes out to be 14 by 5. Similarly, I can find out the other values of the change value, that is 1 by 3. 1 by 3 multiplied by the 5 by 3, that comes out to be 5 by 9, and minus 2 by 3 into 2 by 3, that comes out to be 4 by 9, but it is minus, so it will be plus. So 5 by 9 divided by the 4 by plus 4 by 9, so it comes out to be 9 by 9, and 9 by 9 multiplied by or divided by the 5 by 3 comes out to be 3 by 5. Similarly, I can find out this value. So this comes out to be minus 2 by 5. Now we have to find out the value of z. So z is equal to 4 into 1 plus 3 into 0, that is 4, minus 4 is 0. 4 into 0 plus 3 into 1, that is 3. 3 minus 3 is 0. 4 into 3 by 5, that is 12 by 5, plus minus 3 into minus 2 by 5, that is minus 6 by 5. So 12 by 5 minus 6 by 5 comes out to be 6 by 5. And similarly this value comes out to be 1 by 5. Now since all the values of my z are positive, so I am not able to find out the key column. Since I cannot find out the key column, I cannot find out the theta, and I cannot go further. So this step is my the last step. This is my final or optimum step. So since all the judges are greater than equal to 0, therefore no more iterations are needed. Now we cannot go further to solve this. So this is my final step. So from this table, as I told you, that xb column is my solution column. So I will find out the value of the x1 x2 from this column. Now how this x1 x2 comes, since from this table again I have to find out which one is giving me the identity matrix. So x1 is giving me the first column, so x1 is here, and x2 is giving me the second column, so x2 is here. So if we compare this basic variable with the xb column, so this comes out to be x1 is equal to 14 by 5 and x2 is equal to 4 by 5. When I put these two values in my objective function, this will give me the 68 by 5. Now how we say that there are the three iterations and this z will be the maximum at the 3 1. So we can find out the value of z at each and every point. Since I am saying that this xb column is my solution column and these basic variables will be giving me the solution. So x1, the column coefficient of this cb multiplied by xb will give me the answer. So 0, 4 into 10 by 3, that is 4 by 3. Now this is 14 into 4 by 3, 4 into 14 by 3, and plus 3 into 4 by 5. So I will add these, so 68 by 5 is the maximum of these three values. So this is my last table and this is my optimum solution. So as a recap, what we have studied in this PPT or in this video lecture, that we have studied about the methods to solve an LPP, and we have studied in deep, or we have solved the problem or by simplex method. Now the question comes in our mind that what is simplex method and why the simplex method is used. So simplex method is a method to solve an LPP if, because we are dealing with the constraints, and these are the constraints, these are not the equations. So if these would be the equations, we can solve these equations with the help of the matrices, but these are not the equations, these are the constraints. So that's why we have to use the simplex method to solve these two, the these kind of situations. And why simplex method is used, because we are not able to solve this kind of a problem, these kind of a problem with the graphical method. So graphical method fails, then we have to switch for the simplex method. Now these are the references. You can go for the any of the book to check whether the simplex method is there, the different type of problems are there. You can go to the different kinds of situations to solve the LPP by simplex method. So these are the books which are considered as a references. Thank you so much.